Okay. Let's take this logic and make it a bit more complicated. There's some weird angling here, which I don't quite like. What I'll do is I'll make a new curve somewhere in the middle, divide that curve, and then project those points onto the outside curves. Let's make them a bit more wavy. Good. Okay. So in fact, I'll make the whole thing again from scratch, but this time with 3 curves. Draw one roughly in the middle. We will import this curve and divide it as before. So again, we will use the divide curve component, which by the way you can find in curve division panel. So in division there's ways to divide curve by contours. You can create dash patterns. You can divide a curve into equal length segments. You can divide a curve by controlling the distance along the curve or the distance in space. And there's a bunch of other components which are a bit more expert user than this one. So divide curve is the one we use. Select one curve, namely this one, and I will right away use a slider to control the number n here. You can make a slider by dragging it from the tabs onto the canvas, or you can type slider in here. And there's number slider. But there's even a way to create a slider with preset values, which is sort of nice to have. You can type 1 equals less than 10 equals less than 100. This means that it has a minimum of 1, a maximum of 100, and a default value of 10. So now it goes from 1 to 100, and it was set at 10. Okay. So what I want to do here is take all these points and project them from this location onto those 2 curves. And this projection has to be as short as possible. So it'll find the point on this curve, which is closest to this point. Then we will create a new line from between these 2 points and see how that works. Right? So there's a same here. We'll project this one onto those 2 curves, giving us 2 new points, and we'll make a line between those 2 points. There is more than one way to actually do this. The easiest way is to use the pool point component. I think Rhino also has a pool command which allows you to pool points onto geometry. So it works in almost exactly the same way. Pool point takes one point and it pulls it to the nearest object in a list. So in this case, we will take this point and put it onto this geometry, which is currently not yet set. So we'll go in here, set one geometry. It can be a curve, it can be a surface or a mesh or another point, it doesn't matter. And now we're actually projecting all of these points onto that curve. And I can repeat this operation for the other curve as well. Good. So now we have this projection, that projection, this one went all the way here, and on this side it went the same way. We went from this point to those curves. As you'll see, there's big holes here because the points actually project not to this because it's far away, but it projects to those points which are nearby. If I change the shape of this curve, those points will start to converge in the middle. So it depends very strongly on the shape of this curve and the location of those points, where these points end up. Okay, we now have, for both sets of projections, the location, namely those points, and the distance between the projection. So the distance between this point and this point. We can once again use a line component to connect the points, and now we have the green lines as a result. Okay. We can make this a bit more complicated. Instead of creating lines between these 2 points, we could also take this point, and the original point into account and actually create arc segments. Right? We could choose to actually make an arc from this point through this point to here, and there, and there, and there. As with lines, if you create an arc in Rhino, you have multiple options. You can, by default, it says center of arc, and then it picks the extents. But you can also choose to define your start point, then your direction, and an end point. Or you can choose to have a start point, an end point, and a midpoint. And we will be using this last option, where the start point is this set here, the end point is that point here, and the midpoint is the point here. So let's have a look at our arc components. They too are in curve primitive. So there's lines, circles, arcs, and polygons and rectangles in this one. If you want NURBS curves or catenaries or blend curves, you will go not in primitive but in spline. So they're all freeform curves in here. So we have 6 components that seem to make arcs. We have an arc that takes a plane, a radius, and an angle domain. That's quite complicated. There's an arc from 3 points. That's the one we want. There's an arc SED, which stands for start, end, and direction. There's a bi-arc component, which allows us to create 2 arcs which are tangent in the middle. And we can control both the start direction and the end direction. This does not exist in Rhino as a command. And we can create arcs that are tangent to circles. But we'll just use the one that's arc 3 point, arc 3 PT. It takes 3 inputs: the start point, the interior point, and the end point. And the output is an actual arc, the plane in which the arc lies, and the radius of this arc. These are basically here just because there was still room in this component, because there were 3 inputs. I could have just given you the arc, and then you can use other components to measure the plane or the radius. But oftentimes, there's a bunch of outputs which you might not need, but which are there just for your perusal. So the start point is the same as the line start point. The end point is the same as the line end point. But the interior point was the original division. I just delete the lines and show only the arcs. As I change this, you can see that these arcs some are very curved, some are very straight, some are actually self-intersecting, or rather, not self, but they intersect other arcs. And if we make these curves a bit less extreme, that'll happen less often. So we can actually play around with this and see if we can get it to be a little bit more to our liking. And still play with the division count. Now, of course, you could do this in Rhino. I mean, we're not doing anything that you couldn't also do in Rhino, but it would be very, very annoying to find which number you like best, because it takes a good 2 minutes to actually do this by hand, and it only takes a quarter second to do it in here.